Right, practice problem 5.7. We're in millimeters. Part's origin is located at the end. Symmetric about the axes, and centered. Lines, center line, circles, trim. We'll see about trim. Extrude boss, extrude cut, and planes. All right, so there's a couple ways that we could approach this geometry. We'll probably do the circle on the right plane, centered on the origin. We could do the first 13 millimeters and then do this profile for the next, and then do the end piece for 3 millimeters. Or we could do the circle for the full 80 millimeters and then use the geometry to cut it back. So it is interesting that this shows the arc, but this shows it as smaller. So not not sure what. Oh, this is the pad. So yeah, this would be the 12 millimeters on the outside. So this diameter that's not called out elsewhere would be the 8 millimeters. And then since that's the section view looking at that geometry, okay, that makes sense. All right, so make sure I know what I'm looking at. And then we will get started with a new metric. Right plane, open up the sketch, and whoop, I guess I'm in a click. So let's get a circle on the screen, get it dimensioned to 8 millimeters, and then let's go with the extruding at 8. So I think we'll make a drawing of this as well as an optional exercise. So 80 millimeters, hit the tab, go ahead and hit OK. We'll open up a sketch on the end. And because that is kind of a rectangular shape, we need a dimension, and we'll either do the mirror. If we do the mirror, we need center lines. If we do this as the pattern, we just need the geometry. So let's go ahead and pattern it. We can go circular pattern. We have our geometry. Dimension the radius. The center point will be the origin, if it'll let me pick the origin. If not, let's go ahead and see if it'll finish. All right, so it finished. Not sure why it's not picking the origin, but I've noticed that it has done that a couple times. So 3 millimeters, 3 millimeters. All right, so that is on the pattern. If we want to tie it in, we can leave it driven. All right, and so this one didn't go fully defined. So we're going to grab a couple of points and drag it away from the circle and then drag it back so it's coincident. Also could have picked the point, Control select the perimeter, and made it coincident, but that gives us our sketch geometry to do the undercut. All right, so we're going to do an extruded cut, and I want to stop offset from surface, and that's going to be the end face, and that is 13 millimeters. All right, so that makes the cut. And then the end geometry, might as well go ahead and get that out of the way, is 12 millimeters. All right, going into the smart dimension, 12 millimeters, okay. Features, extrude, 3 millimeters for the thickness. I'm going to give it a glance, and it is going the right way. All right, so if we want the flat, it has the detail view and the geometry. So we can go about this a couple of ways. We could start the sketch on the top plane and draw a rectangle, or we could start the sketch on the front plane or right plane and go to the side, or more likely we're just going to pick the end face and create our geometry. So if we go with the rectangle, we are still doing the corner to corner, and we'll get that close. Right click and select, and then we'll see if we can get a coincident. And then I could either draw the center line, or we right click and select the midpoint. We can search across those lines and try to find the midpoint, but the select midpoint is always going to find the midpoint of that line. All right, so control select the origin, make horizontal, I think. Okay, we got the horizontal relation. The width is given as, and I know I saw that, we had a depth. Now let's bring it back in so we can find it. Okay, so that's going that way. All right, so there's no dedicated, so we're going to assume tangency to the 3 millimeter diameter. So we can go to Smart Dimension there, place our dimension. Really, it doesn't, we could put a dimension on this as long as it extends past, and we should be okay going with a tangent. And then this is going to extrude cut. Oh, I went to the wrong one anyway. All right, so let's fix that. It's one of the reasons why I will do the rotate, is to make sure that I'm seeing the sketch the way that I think I am. So highlighting the boxes. All right, so any of these that we want to get rid of, we can select those green boxes. And I'm going to drag until I see the coincident, and the midpoint takes care of that one. Tangent, well, now it is definitely got enough. Oh, I didn't complete the extrude cut. It is going to go 11 millimeters. So we put a blinding condition of 11 millimeters. Then we have our geometry. All right, so I am going to introduce the hole wizard on this one, and we said we're going to make a drawing for this. So they give us a diameter of 3 by 4 millimeters deep, and I want to select the face. If you pre-select the face, it saves the questions later on of what it's doing. But one of the advantages of the hole wizard is it gives us this property manager where I can select for counterbore, countersink, hole, tapped hole, tapered, or pipe tap. And then the legacy is everything like before 2004, 2005, somewhere in there. Because this is in metric, we're going to pick the ANSI metric standard. I'm going to do a standard drill size, and it is going to be 3 millimeters in diameter. And not through all, we want a blind in condition. But the advantage of this is this hole is typically going to be drilled. If we're manufacturing this part, the design for manufacture has some issues right away, but we'll have that discussion in a little bit. But no, I'm not going to do the near side countersink. Countersinks if it is for a specific purpose, but for the most part, we do enough to break the edge and not have a sharp corner there. All right, so the two icons here are going to be depth up to shoulder or depth to the tip. We have 8 millimeters. Going to the shoulder is only going to add a little bit more. So when we go to the positions, then I am looking at select, control, select. All right, center of the circle to the origin, and that's going to be horizontal. And then from the edge to the center of the hole is 5 millimeters, and we go ahead and hit OK. All right, so the advantage, and I did something because that doesn't look deep enough. 3 millimeters. Oh, and it reverted back to something for the 0.5. So let's put 4 millimeters and see what that looks like. All right, so as I was saying, the advantage of doing the hole wizard is we put the 3 millimeter diameter in there. If I want this to show as a dowel pin in the drawing, it will give me the target if it is set as a dowel hole, but then it usually has an additional there are additional tolerances that are associated with it. If we want to go over to an M3 by 0.5, I can switch it and it will do the tap drill, and then it will show me, hopefully it will show me the, I don't know, it looks like it broke out the backside by just a little bit. Didn't think it was going to be that deep at 4 millimeters. Well, we took maybe half a millimeter off. Yeah, it broke out just enough. So one of the other advantages of our hole wizard is, oh yeah, the tap is going to need to have a little more depth, so it went to 7.5 millimeters. If we were to change that to the tip, the thread only goes, but when we look at a tap, it has 2 or 3 unusable threads at the end to help it start the thread into the top of the hole. And so that doesn't break through, but it makes it deep enough that we can get the tap in there and probably get our 4 millimeters. All right, so it tells me I'm at the 3 millimeter tapped. I'm going to go ahead and leave that. The drawing will have a little bit more interest. All right, so one of the issues that I see immediately is round tools do not cut square corners, square holes. So one of these, depending on the direction, will need to have a fillet in it so that we can bring an end mill in, go along that edge, and have something that's manufacturable. The interesting part would be that, do we want to go side to side and then flip it over and go side to side? But as it is, I can't make those square corners. I make those corners pretty small. If we took a 1 millimeter tool with some extended reach, I could get a 0.5 millimeter radius in each of those corners. But now we're injecting cost because small tools cannot go very aggressive. So let's go ahead and do a design for manufacture on this and say we're going to put a 3 millimeter, whatever that worked out to. A 6 millimeter would be nice. Diameter of the end mill, the tool to go in there. So I'm just going to select those items, pick my fillet, and let's go with a 3 millimeter. That's still pretty big. I didn't measure to see what it would work out to, but 2 millimeters not bad. All right, so if we were to go with a 4 millimeter, which is pretty close to a 5/32 end mill, that is something that I could set up in my vise, bring the tool in, go through the corner, flip it over, and do 2 sides. All right, so as long as it's the opposite 2 sides, I'm going to be able to get these 2 at the same time and then flip it over and get the other 2 at the same time. So that helps a little bit. And this is fairly small, 8 millimeters by 80 millimeters, a little, pretty close to 3 inches. So let's go ahead and save this, and we'll take a look at the drawing. All right, jump back into that. See if I can. So I did a rename, and just went ahead and put the levels since I got off one on my assignments. We'll go ahead and put the levels in there so I can keep them straight. All right, so P5-7. Okay, to make a drawing for this, then we are looking at make drawing from part or new and drawing. Either one of those, because we haven't created any document templates, are going to take us to the sheet format. All right, and our sizing, let's go ahead and uncheck the only show standard formats, because the first time you run drawings, that is probably what you're going to see. And so the ISO A is really huge, and then 1 is pretty big, bigger, a little bit smaller, and then we go to the A4. All right, we're going to stay with the ANSI though, so you want to make sure to uncheck this only show the standard formats. And then for our scale, one of the things has always been a complaint about the A size, and when I do the a simplified drawing template, we'll take and condense this down to where it's not taking up a third of the sheet. But a B size looks pretty good even if you print it on an A size sheet. So the way this works is A is your standard letter, 8.5 by 11. And then if you were to take and unfold 2 of them, you would have the 11 by 17, the B. The C side unfolds again, doubles in size. The C or the D doubles from the C, and the E is just really huge. So let's stay with the B size in this case. And it's asking me by default, this command for the property manager is always going to start unless we uncheck it. We can use the view palette, and we'll do both ways. But we can go ahead and accept P5-7. Our little next arrow is going to take us to what do we want to show. And so for the view, I think we'll go ahead with the front view. The right view is going to be that details section. So let's just go isometric and from the front, and we'll go ahead and accept that. All right, so that gives us our wireframe. We can display it in different, all lines solid, hidden lines visible, hidden lines removed. I don't recommend shaded, and shaded without edges makes it a little bit softer. So we have our isometric view, we have our front view, and so we could go ahead and set up our detail. So under the drawing, we're going to have all of these other items to work from. And as a process going through the iterations of the design, from the part to the assembly to the drawing, and then refining the drawing, at some point we're going to look at the tolerances, but this gets us started. And realistically, I probably should have reversed those. So things that you see as you go through, but if I had reversed, I would have one setup, meaning that if I had put the fillets on this corner instead of that corner, if I'd cut that, I would be able to do this flat, the hole, the drill and tap, and then also be able to bring the geometry in. So that's something to change, and because of the associativity, then that is also going to be able to be something that we'll update. So if I go back and fix it, we can edit the fillets. I'll just clear out all of those sections, and we'll go this direction instead. And I'll just pick those and make sure that I am picking the right directions. Again, I don't want half on one, half on the other. Okay, so if I go Control-1 to the front, now my tooling, my end mill, my setup for the machine, when I put this in, I can create this geometry. The tool can come in this way, go off that way, and I have geometry, and I've minimized the manufacturing process. So we go back to Window, Shift to the sheet. It rebuilds. Now instead of the radiuses going the other way, they go the correct way, if there is such a thing. Our detail kind of needs to rotate. All right, we're ready to start adding adding dimensions. I'll do the break and the section view after we get our items started. So let's get into the annotation. All right, so 3.15, we defaulted to inches in this drawing sheet, so we can pick up that geometry. Let's see. Well, let's keep going with the dimensions. I was just kind of thinking which way I wanted to go. All right, 0.51 for the 13. 3 millimeter on the end for the 1, 2. All right, so this is rounding. For geometry, it's rounding up or down depending on what we end up with. We have a tool called hole callout, so if I left that as metric, or the metric tap, it's going to give me all of the designations for the tap drill, how deep to go with the tap drill, and then where the tap goes. And so that still doesn't, oh, well, yeah, that does look okay because we are now in inches. I got to keep that reference in mind. All right, so back to the drawing view. Oh, let's go ahead and put, trying to reproduce what they had. So let's go ahead and put the hole call out for that. I'm not seeing the cosmetic thread though, so I'll have to check on that. Usually there is a simplified thread form that shows up that also helps to designate it as a tapped hole or tapped geometry. All right, so let's kind of move that off to the side. We have our dimension. We'll dimension from the end and then pretty much on center. All right, so going into the drawing, let's go ahead with the section view. It's going to be a vertical section, and we'll pull off of that, that end. All right, so when this folds up in our first angle projection, when this folds, it's looking this way. That's why we don't have the circle. So I want to flip the direction, and then just to be on the safe side, we'll rebuild. And I'll bring that a little bit closer. And it goes orange to tell me that it needs to update again. And we'll pull the section out of the way, go back into the annotation, pull the radius and then the diameter. So that one still can be a diameter. And just like we do in the sketches, if I want to see it as a diameter, I can always switch it. So maybe we'll put that to where it makes a little more sense. And then we can pick up the distance between and verify that geometry. So from there to there, nope. Let's Control Z so I get back out of that. And I think I backed out of it all the way. So we'll go back to the smart dimension, 0.12 for the 3 millimeter. Okay, so they did 3 millimeter typical. I just put dimensions on both of them. All right, so for the break, this isn't really that big, but let's just say we did 2 to 1. It may be a little more apparent if I wanted to go to 5 to 1 is going to be way too big because this is already 4. So if I do user defined, and I'm just going to bump it up to 3 to 1. All right, so 3 to 1 takes over a little more space. I can go to the custom scale for the isometric view and shrink it back down a little bit. But this starts to eat up a certain amount of space, and if this was way longer, we would want to reduce its footprint on our screen. So we have a cut direction, and a gap size of 10 millimeters, 0.39. The line style is wavy. Add a horizontal break line, add vertical break line. So these are going to be vertical, and when we select is outside the view in which the break line is being added. Okay, let's make sure I have that view selected, and then we'll do the break line. Okay, so we should see that preview immediately, and then we go from there to there. That shrinks the depth, and it didn't really do the zigzag, but it did bring the depth or the length down to the geometry. All right, so that pretty much reproduces what they had. We have some better geometry for manufacturing, and if we're going to do the typical, or I could tell it that it's going to do that 8 times. So wherever we see those radiuses, then we'll be able to pick that that geometry. So we'll end this here. I think this is a good part to introduce the drawings with, and being able to create those views and have that geometry worked into a document is pretty handy.